not a game, it's a rich thing.
Prepared for block assembly. So far I've taken the caps off. I wanted to inspect the base of each cap to make sure that the bearings had not had any type of chafing or any type of scoring from walking around. So that way, once we build this bad boy up to make some serious horsepower, we can then remove all the caps, inspect the block, inspect all the surfaces to see if these bearings have been rocking or the main bearing caps have been shifting. We do have a block girdle, which is reinforced, so it's pretty thick aluminum that'll help keep the block steady. But we want to just inspect everything because this 3.6 is possibly going to exceed a lot of the horsepower compared to all the other VR6 blocks that's on the market. I'll just say that starting off. Anyway, I've taken the caps off. I've installed the oil squirters for each one of the pistons, and the 6 of them, as you can see, 1 through 6. Number 7 bearing cap doesn't have anything because it's a 6-cylinder, and each one of these are positioned on an angle so that way it can squirt oil into the bore itself, the cylinder bores. I have the main bearings in position. I'm about to torque them down. The piston oil squirters are all in position. I took the bearing caps off because I wanted to inspect each of the surfaces just to see if there was any potential of the bearings shifting from this block. Everything looked good. The block has been tested for line bore and everything was in position pretty good. One of the things when installing the bearings, I like to make sure each one of the bearings is lined up perfectly. So, for example, this position right here, before I even torque the bearing in position, I'll make sure I'll just rub my finger across, make sure this whole surface right here is perfectly flat. For example, if I lightly tap, you'll see a lip right there, and you want this to be pretty much in position. So I'll lightly tap each one of the bearings in position, run my finger across, make sure I feel a smooth surface, no type of lip, before I torque everything into position. But right now I'm just only doing a test before I torque it down, just to measure each one of the bores between the crankshaft. Okay, we have a slight dilemma. As you can see, I have ARP hardware out, bolts that I've ordered from all over the place, even Integrated Engineering. The bolts that are supplied with the torque plate, I am not happy with. These are the bolts that came with it. And they're rated at 12.9. So that is one of the hardest or highest rated tensile strength metric bolts that they just sell standard off the shelf. My dilemma is this is only rated at 1200 psi tensile strength. These ARP studs, these are head bolts. These are the main studs. These are rated at 180 psi tensile strength. So you can feel the weight difference in the bolt. This versus the ARP, this is more solid. I mean, the density of the bolt, you can hear the thunk in the metal itself. This is just a lot more of a solid bolt, a lot more heavier. I don't want this bolt to stretch, especially if this block is twisting back and forth a little bit from the torque. And any type of shifting like that, of course you want this to help, but this is not going to help at all much if these are stretching. So I will do some research to see if I can come up with some ARP studs with the same thread pitch, and that is the factory length bolt. So this would be the factory stud. Of course, with all these threads, you can see how this would stretch. This is still a pretty nice bolt. To me, it's better than the factory bolt, but as I stated before, under high horsepower, it can still stretch. And of course, an ARP stud. So I'll do the research and see what I can come up with if we can find a stud. This stud fits perfect. It's just so long. If it's perfect inside here, that will work out great for torquing. The only downfall, like I said, is just so long. I can thread it. Into here, and as you can see, we easily have 1.5 inches, almost 2 inches of overlap. Now, it's a possibility I could get some hardened shims and still shim it, because if this was bolted in position, they would stick out the oil pan about that height. So this doesn't have a oil driven pump like 3.2, so the thickness of the oil pan may work out, because even if the studs protruded out like that, that may not hurt much, because they are still, they will still have a lot of clearance. But either way, I want to find the right studs, so that way we know this is, we're going in with a pretty solid and stout block. If we're using anything else, then we're guessing, especially with the numbers we're trying to push. So I will research as well as call ARP up to see what we can come up with. Something that appears to be different from this 3.6 liter block is the ARP studs that they sell. So these studs apparently doesn't go down as deep in the 3.2 liters as it does the 3.6. To me, it's good that you're going down further here, because that means you're grabbing even more material, so you have better stud to cap clamping force, which is good. The downfall is the studs are short, and as you can see, we're easily coming up 2 threads across the top of each one. Once I torque them down, it'll probably be like 1.5 threads, but the thing is, it's still short, and that's not good. You want as much of the surface area to surround the stud as possible. But either way, I'm going to research getting some new bolts and studs, because we have a block girdle, and this block girdle came with grade 12.8 studs. Now these studs, they are a lot lighter than the ARPs, but I do not think they have the clamping force. The tensile strength that I researched on these was around 1,200 foot-pounds, and the ARP studs come in at 200,000 psi of tensile strength. So we definitely want to get some nice ARP studs or aftermarket performance studs that'll go through this torque plate down into the block itself. Taking measurements of the crank journals. I'm using telescoping gauges to check the crank journal clearance. And one of the gauges I was using actually have a little dimple, like a manufacturer's dimple, if you can see, right in the center. Right there was getting throw off the measurement a little bit. So I got some fine grain sandpaper and kind of sanded those little pointers off on the tip of each side of these, as you can see, so that way it's not like a little sharp pointer and that can throw off my measurement. So I kind of wanted to kind of at least flatten that out a little bit so that way I can get somewhat of a better measurement. Okay, I want to take my measurement right where the caps connect and bolt to the block surface itself, and I'm going to take the measurement here and up and down. That way we can see if there's any type of stretch or distortion, and we can still measure the distance between here. I doubt seriously if there's going to be any type of expansion between here side to side, because more likely it would destroy the bearing before we see much play right there. But that could still give me an idea if the block starts to flex quite a bit, and if it did, and it's cast iron so it would crack, but if it started to expand right here, you pretty much have somewhat of a hairline crack down the block. With my gauge zeroed out, I'm receiving 65.6 millimeters on the cross section, and I'll do top to bottom next. You gotta be careful not to squeeze at 65.5. Taking my next measurement from the block journal to the cap journal. Okay, I'm getting somewhere around 65.18. Okay, if I rotate on the inside with the gauge itself, somewhere 65.13 millimeter. As I'm rotating it around, you can see the numbers are changing. That's very close. I have the main bearings in on the lower side. I lined up all the holes for the oil ports, and I just lowered the crankshaft into position. So now I'm about to get some of the plastic gauge, cut the strips of the plastic gauge and mount them on just a little piece on each one of the crankshaft journals, and then I'll put my main caps in position and torque everything down the spec and to measure for proper clearance. Everything should be working out fine because the crankshaft was not damaged in any way, and the machine shop checked the line bore and everything tested out perfect. I did some measurements also with a micrometer and telescoping gauges, and everything still appeared to be on point just as the machine shop specified. I am currently cutting a plastic gauge into small strips with the scissors, and I'm about to perform surgery, so I got some tweezers and I can slowly pick each piece up and place it onto the crankshaft journal. So this piece I made it a little bit longer. I'll be able to see the crush, but I will install the shorter pieces on each one of the main bearing journals. I've installed small strips of plastic gauge on each one of the journals, as you can see. And now I'm about to install the main bearing caps and torque them down to spec. Okay, I installed the ARP studs. I'm going to slowly run them down. You don't want to sneeze or send a big puff of air, because then you can blow off the plastic gauge off of any of the journals. So I'm slowly running each one of the studs down into position, and then I'll install the caps. Then I'll slowly tap each cap into position. Okay, I have the main bearing caps on, plastic gauges in the middle. As you can see, I haven't torqued it down to spec. I'm going to slowly tighten the bolts up to draw the main bearing caps down by hand first, And then the torque specifications for these are 60 foot-pounds. So you have to torque it in 3 steps, 20, 40, and the final step is 60 foot-pounds of torque. I'm using a snap-on torque wrench to torque down all the bolts. And even though it's 60 foot-pounds of torque, you can feel that it's still a lot of force. Normally I'll have one hand here and the other hand steadily just like balancing this part with my thumb just to keep it centered and not putting any extra force, because you don't want to affect the torque, but just giving an example of a video shot of it. Okay, I have all the bearings torqued down into position, as you can see. And you can kind of see where it crushed in there. Of course, you want the bearings dry. You don't want any type of oil or anything in there to offset or have an effect on the crush of the plastic gauge. And of course, you definitely do not want to rotate the crankshaft or move it out of position, because that'll smear the plastic gauge and throw off your readings. So everything's torqued down into position. Now I'm going to remove the main bearing caps and check the clearance on each one of the journals. I am now removing each one of the studs. I took the nuts off, and as I stated before, you want to use extreme care not to rotate the crankshaft. So for example, if I was going to remove this nut right here, I wouldn't want to make a mistake and tap down on this counterweight and cause the crankshaft to rotate. So you want everything to stay nice and in a fixed position until you can get all the caps off, and then you can check the clearance on each one of the journals. Okay, everyone has their technique of removing the main bearing caps, but they're fixed in place kind of tight once you torque them down. So a lot of times I've in the past used big jaw channel lock pliers just to try to grab them or get them out of position, and I discovered sometimes just use a simple awl, putting it in position and then tilting back. As you can see, when I tilt back, I come up off of that part of the crush bearing. A lot of times you want to avoid from rocking side to side to create any type of additional crush, but just rocking this part up this way onto the opposite side. And as you can see now, I still have a gap in here, and I'm slowly rocking it until it comes out of position and not adding any additional force on the bearing cap. And as you see, I just rocked it back and forth, and then I just took it straight up. And now I can clearly look at my crush pattern, and just visually looking at that, try to focus in a little bit better. That looks pretty good. But anyway, I'm in the process. Like I said, I'll remove the remaining caps, the main bearing caps, and the same manner, and then go ahead and check for my clearance. I have all my main bearing caps removed, and just from checking on the bearing side itself on the cap, the crush pattern looks very consistent, so that looks very beautiful. As you can see when I'm zooming in, it's pretty much a consistent crush, which is telling me I'll get pretty much equal oil lubrication throughout each one of the bearings. And as I stated before, the machine shop checked the line bore, so the line bore was good. These bearings, the clearances on the bearings are good also. Sometimes you can get a defect or have defective bearings, or mistakenly order the wrong size bearing. These were standard bearings, so if I ordered an oversized bearing by mistake, or it was even shipped one by mistake and went to install these, it would crush too much and alert me that apparently I had the wrong bearings installed. And pretty much like I said, looking at the crank itself, the crush pattern is very good on each one. And of course you can see in between each one where it crushed, but a little bit of the plastic gauge is like left where there's an opening and it didn't crush. But overall, it looks very, very good and consistent. And one of the definite important journals to take a look at would be the side that the flywheel or flex plate mounts to, because a lot of times they're going to be end slop, and just from the torque of shifting gears, anything that creates some type of distortion or flex like that from shifting, and sometimes engines will have a tendency of wearing out this bearing a little bit faster, because this is handling a lot more torque, and where your drivetrain is being driven off of this side of the hub. Okay, I just removed all the caps. Everything looks very great. For this VR6 engine, you want to crush pattern measurement anywhere from 0.02 to 0.06, and everything on here is lining up very great with the specifications. So I'm right in spec. If you can see right here, this lines up at 0.051, which is pretty good, which is great. So my whole point is this: they don't have these crankshafts in the VR6 engine running so tight that you have to worry about spun bearings. And when we originally disassembled the engines, the bearings look very great. I mean, to the point where it was almost like you want to reuse the bearings again, because they was in such great condition and very little wear. On the crankshaft itself, that is the most important part right here. This is coming within the spec again and looks great. So if I come down, check my tolerance, right on the money, 0.051. All of the clearances on the crankshaft is very consistent and look great. And of course, like I said before, this tells the tale with each one of the main cap bearings, showing the crush pattern of the plastic gauge, and everything here is consistent as well. So now that I can go ahead, clean up the crankshaft, clean off the plastic gauge, pull everything up into position, and put the crank back into position. So what I have is racing high performance assembly lube for the engine. I'll use the assembly lube on each one of the bearings, and that helps with the break-in process, and also not to create any type of premature wear on any of the bearings. Lube my bearing caps up, lube the journal itself, and put everything into position and torque it back down to spec.
It's not a game, it's a rich thing.